Alrighty. Well, hey, good afternoon, everyone. Welcome to the Monterey Bay Aquarium here live. Oh, not even the Monterey Bay Aquarium. We are live on the Monterey Bay Aquarium social media feeds and the Monterey Bay Aquarium Research Institute, or MBARI's social media feeds as well. Welcome, everyone, and thank you so much for tuning in. My name is Patrick. I work at the aquarium and social media. Joining me from her home a few miles away, we have the other half of the social media team at the aquarium. We've got Emily. Emily, how are you doing this afternoon?
I am fantastic, Patrick. Thank you so much for asking. How are you?
Oh, we're doing great over here. I'm just playing through a few of my favorite video clips here from the MBARI catalog. Here we've got the mystery mollusk up on screen. We started off with a bloody belly comb jelly. We've had a few other animals go by here, and actually here to talk a little bit more about the amazing life, like this carnivorous harp sponge that is up on screen. Joining us now to talk a little bit more about these amazing organisms that we find out here in the deep sea of the Monterey Bay. We have Susan Von Thun of MBARI joining us. Susan, how are you doing today?
Hi, I'm good. Thanks for having me. I'm super excited to talk to you guys about the deep sea.
Well,
We're very excited to have you, Susan. Thanks for joining us.
So exciting. I'm going to go to Susan and Emily. As far as you can tell, can the folks out there hear us at the moment while I play a giant larvation? They hearing us? We coming in loud and clear?
Yes, absolutely. I can see the chat popping up for me here across our different social media pages from Twitch and Periscope, YouTube, Facebook, both our channels and MBARI's channels.
Oh,
Everyone
that's so
is
exciting.
tuning in.
Well, hey, good afternoon, everyone.
Right.
Thank you so much for being there. Put see life that we have out here in the Monterey Bay Submarine Canyon. And let's talk a little bit about that canyon, because here at the Monterey Bay Aquarium and at the Monterey Bay Aquarium Research Institute, we're very fortunate to be located next to a superb deep sea canyon that is located, as you can see right here, goes directly into MBARI to be able to head out into the deep sea and go and study. Oh, of course, I pull up a video that doesn't exist. There's MBARI. Those researchers are able to head out to sea very quickly and go and explore the deep sea, whereas in other places around the world, it might take many days to get out to the spot, then many days to study what's going on out there, and then many days to come home. Here we are very fortunate to be able to head out and have immediate access to the deep sea. There's the Rachel Carson in the Moss Landing Harbor, and aboard the Rachel Carson is this ROV, or remotely operated vehicle, Ventana, that dives down into the deep sea here to help us record videos of what's happening down there in the deep. So ROV Ventana is where a lot of the video footage that we'll be playing today is coming from. MBARI also has the RV Western Flyer that heads out around the coast here, and we have ROV Doc Ricketts on board there going into the deep sea. That's what allows us to bring you these videos. And right now here on the RV West, we know very well as one bit about what it's like there to be on those ships, and then we'll start talking about our topic for the day.
Yeah, that's actually me in that video clip.
Perfect. I nailed it. Got the right clip.
So I spent 18 years working in MBARI's video lab, where we are the ones who take all of the video from the ROVs and we analyze it back in the lab. So we have a system called VARS, which stands for Video Annotation Reference System. And we use that to annotate every video that we take in the deep sea, which is really unique in the world. There are lots of submersibles and ROVs in the world, but we're really as a video lab staff, I have watched literally thousands of hours of video, and I've also spent plenty of time at sea, and it's really an amazing experience to be at sea and content management position. And I'm really passionate about talking about science communication and sharing our research with the world, because it's something that most people, that bloody belly comb jelly, is something that we see relatively frequently in the deep sea, but this animal lives hundreds, so thousands of feet under the sea surface. You can see that it's a deep red color, and a lot of the animals in the deep sea are this red color. And that is because as we lose light and go deeper into the ocean, there is the first wavelength that disappears is red. So essentially red becomes invisible in the deep sea. So there are a lot of animals like that, ctenophore, and now we're looking at Tiburonia gran rojo. That name actually comes from Tiburon. Tiburonia was named after our ROV Tiburon, which was retired many years ago. And gran rojo means big red. And it's because this jelly is 3 feet in diameter, which is amazing. These things can get really, really big. Sometimes we've seen them maybe, just a foot in diameter, but biggest ones have been over 3 feet wide. And you can see it's this very deep red, like the comb jelly that we were looking at. And this essentially camouflages the animals in the deep sea. It's totally dark down there, but there is a little bit of light that is streaming down depending on how deep we are. And there are a lot of animals that are creating light in the deep sea.
That's right.
So
and sorry to interrupt, Susan. I just wanted to point out that I have deep staria here up on the screen right now, just for the folks that are watching. That's deep staria that I have there up on the screen right now. That brilliant red jelly there.
And deep staria is a really unique jelly that there are quite a few videos on the internet that have gone viral that were from other institutes that maybe didn't know exactly what it was, and people were guessing what it is, and they didn't know that it was a jellyfish. So as a result, we put together a video on our YouTube channel that we worked with one of our biologists, Steve Haddock, and it describes exactly what exactly this animal is and why it looks that way. Color. There's another species that isn't red, that's more of a white color. But these jellies also get quite low. How big are all of these things?
Yeah. And actually, Susan, that brings up a great question that I've seen here in the chat. These deep.
Yes, but we have definitely seen them in this area in the North Pacific. But I believe that they may even be a worldwide species. Yeah. So they're throughout the deep sea. There are many of these animals that we took ocean to the Atlantic.
Yeah, you were mentioning there, Susan, just that color, that bright red color that we see in so many different jelly species. I have, let's see, giant jelly Stygiomedusa here on screen. You're mentioning that red coloration is something that we find in so many different organisms. We've talked about it on the previous time that we were talking about this, but that coloration is a really good way to camouflage because that red disappears, but then other animals are making their own light in the deep, and a lot of that is blue and green light. And so here I have the Tomopterus dancing bristleworm there with the red gut that is there to hold on to any light that might be escaping from its belly so that it doesn't give itself away. And Emily, it seems like Trooper there in the background has
Trooper's joining the chat today too.
Trooper's in the chat.
He loves Tomopterus worms.
Exactly. So Emily, I wanted to go to you and see what are some of the main questions that you might be seeing there, and then lead us into a discussion about more deep sea camo from what people are asking, because that brilliant red coloration, we've talked about that. What are people wondering over there?
I actually think that this is going to be a great lead. And first of all, shout out to George Matsumoto, who joined us on our last deep sea talk. He's been hopping into the chat answering a lot of the questions, but one of them that I saw over on Facebook for you, Susan, we've been talking a lot about these jellies. What kind of food do deep sea jellies like to eat?
Oh, great question.
Yeah, that's a good question. And it's different for each specific jelly, but a lot of them, like those big ones, Tiburonia and Stygiomedusa, they don't have the little tiny frilly tentacles that other animals do, other jellies do. They have more like um, sticky things on their arms, so that those Tiburonia, those are actually called oral arms instead of tentacles. And things, basically, they sort of passively just catch things. And as you can see with this curtain of huge, long, streaming tentacles from the Stygiomedusa, they catch all sorts of little tiny plankton, essentially, which are anything that can't really swim against the current is considered plankton, which is probably true of most of these jellies as well. And this Stygiomedusa, I also want to point out, can get to be really, really long. Like those long arms are something like 10, 20 feet long. So they're very, very big. The bell of the jelly that you can see pulsing is probably a few feet wide.
Wow.
So I like to think of it as like a curtain of death in the deep sea. So they will pretty much kill and eat anything that gets caught by them on their sticky tentacles.
Now, I did just want to apologize to anyone who might be watching who's wondering, where are the other animals that are red? That's just on me trying to fly through the menu system here. But yeah, Stygiomedusa, incredible deep crimson red jelly there, feeding on different plankton, and maybe on something like this giant ostracod that you can see going by. This is a type of crustacean, so related to shrimps and crabs, etc. So this ostracod, you can see big red belly there, or big red body that's helping it hide there. Of little shrimps like that might be on the menu. But I did want to go back to something that that you mentioned earlier, Susan, which is that you've got red squid, Histiotuthis here up on the stream, because it is a red cephalopod, so related to octopuses and cuttlefish and other squid here. It's bright red, and it's got these little specks on it that make it look sort of like a strawberry in our eyes, so those little specks there. But this is an example of an animal that not only has its own type of light that it emits, but also uses that bioluminescence, that animal light that other organisms are putting out there to hunt, right? So here's that Histiotuthis there. Let's talk about that a little bit.
So what's really cool about Histiotuthis is that, as you can see, the obvious thing that I don't want to pass over is that it has one little eye and one really big eye. Yes. And this is also for hunting in the deep sea. This is an adaptation that it has evolved over, many, many thousands of years, to have one eye that can essentially, that bigger eye can to detect very, very faint light. So all of these animals, 75% of the animals in the midwater, which are these animals that live above the seafloor, never touching the seafloor, 75% of them are capable of creating their own light, called bioluminescence. And it's very common in the deep sea. So that's why all of these adaptations, like the red color and this very special eye that can detect very low light, it's really important, and it's so common in the deep sea. A lot of people wonder, well, why do these animals even have eyes? And they do, because there is a lot of communication going on using the light that is created by the organisms that live there.
Right. And so I'll just transition over to a different type of animal altogether. Back to a jelly. Here's a dunce cap jelly that you can see is crimson red, but then here's some video from the lab of a dunce cap jelly bioluminescing, making that blue-green light there. So it is a fireworks show in the deep sea. It is certainly pitch black in terms of sunlight, but all of these animals down there are making their own, many of these animals, like you said, 3/4 of them are making their own light. And if you consider that the deep sea is the largest habitat on the planet by far. It's actually more common for Earthlings to make light than to not make their own light, if you consider just how many species we found that make their own light. So that's some dunce cap jelly bioluminescence right there. And then heading back over. Yeah, go for it.
Well, and also just want to say that we think that this one is kind of like a burglar alarm. It's not actually luring prey in. Like there are some animals that do that maybe we can get into, but this is kind of like lighting up, and it's saying, it's kind of startling a potential predator and saying like, I'm dangerous, I'm sticky, I'm stingy, and I light up. That's what our current thinking is with a lot of these jellies.
Yeah, very, very cool stuff. Yeah, that burglar alarm. And then just I wanted to go back to the strawberry squid just for the transition. So we got the strawberry squid with those little specks on it. They're kind of making their own light to disguise the shadow of the squid, is my understanding, right? Right, Susan? Those little photophores on the back.
They do have some photophores. I think that all of the speckles, though, are actually chromatophores, which is a different type of camouflage for squid.
Gotcha.
They have ways of changing the color of their skin in really amazing ways. And we actually just had some researchers put out a paper recently that talks about how Humboldt squid can change their coloring, and they actually we have video clips that you can see. We have a YouTube video about this too, where half of the squid is red and half is white. I mean, it's really remarkable how they use this communication, and what the researchers suggest. And actually in this clip you can really see it. Half of it is one color and half is the other color. For a second there you can really see it, and it's showing that when they're in groups, often these Humboldt squid are attracted to a bunch of fish. It's like a school of fish, say, for an example, and they're communicating with each other and sort of saying, watch out, I'm going for this fish, so that they're not having to compete with each other for the same fish. It's really remarkable.
That's amazing. All right, we've covered a little bit of red coloration, some bioluminescence, a few different things there. Emily, let's go to the chat. Let's go to the audience. What do they want to know? What are you seeing out there?
We've been talking a lot about what things that these animals are eating, kind of the adaptation for being red in the deep sea and bioluminescence. Patrick, there is a crossover of all three of these where certain animals in the deep sea actually have red in certain parts of them to help with that bioluminescence. Susan, do you want to talk a little bit about that?
Let's go to it.
Can you see? Yeah, why don't you bring it up?
Are you referring to the viper or the dragonfish there, Emily? The viper fish? Excuse me. I'm just going to pull up a viper fish. I'm going to pull up the shiny loose jaw real quick. I believe that's what we're referring to, right?
Yeah, that's what she was talking about.
I think we got it. No, the shiny loose jaw with that with the red headlamp on the front there. I believe. No, I knew that's what you're going for, right, Emily? I just had to find it. I forgot where it was.
Yeah, not entirely, but this is cool too. Shiny loose jaws are amazing. So
yes, this is called a dragon. This is a dragonfish, and they're really unique because they are one of the very few animals in the deep sea that can see red light. So their eyes have specially adapted so they can see the red light. And then you can see that they have this little bit of a red light. They're essentially emitting red light under their eyes. So they have their own secret, basically, night vision goggles. And so none of the other animals can see the red light, but they can. So they're sort of illuminating the area around themselves. And then their black color, that very deep black color, is also another type of camouflage. So that black will also allow them to sort of disappear into the watery habitat that they live in.
That's amazing. Yeah, and the shiny loose jaw there, as I understand it, they have a gland there at the front under the eye that has some bioluminescent bacteria in it that are making the blue-green light, and then they have a filter that shifts that color red, thus giving them night vision in the deep sea, allowing them to illuminate those red animals there. Emily, what was your exact reference? I'm sorry, I've got afternoon brain. Yeah,
That's okay. I was going for kind of the much more obvious adaptation here. There are certain animals in the deep sea that have red guts in order to block that bioluminescence.
yes.
Other animals are bioluminescing.
So he showed that Tomopterus worm.
It's back up on the screen now there, Susan.
That's a good example. There are also quite a few jellies, I believe, that you might have clips of that are the same thing, where it's a clear animal that also is great camouflage in this like water world that they live in. And the red gut is actually camouflaging all of the bioluminescent animals that they've eaten. So it's like little crustaceans, little things that do light up, that blue-green color that's more common in the deep sea, and they basically, those animals might still be lighting up while they're digesting them, and so they cover that up so that they don't become prey themselves by luring in a predator. So all of these jellies that Patrick has been showing are this is a tiny little jelly, and you see the red gut is hanging down in the center. So this jelly might only be like, say, a centimeter, less than an inch wide, its little bell, and then it has these 4 tentacles that stream off and actually sort of try to catch prey and possibly even lure them in.
Yeah, and then just
the
go.
Tomopterid worm.
Yep.
I just want to mention how big these guys get. They're also not very large. They're probably, most of them are only a few inches long at most. I have seen some really big ones that are about the size of our detritus samplers on the ROV, which are about a foot tall. So I have seen really large ones, but most Tomopterids, these little amazing swimming worms, are just like less than an inch long.
And these are some of our favorite worms for sure. I don't know if there are any worm fans out there, but if you need to have a favorite worm, this is a good one to have. There's really amazing video that you have on your YouTube channel, Susan, for Mbari, the dancing bristleworms there. And then to Emily's point, the red gut there hiding that bioluminescence, the translucency there for extra camouflage for itself. And then the bristleworm also makes its own bioluminescence, and sort of related to your burglar alarm that you were mentioning before. This is sort of like if the burglar alarm was from Home Alone, because the dancing bristleworm can emit this yellowish goo that, as I understand it, is a potential danger for a would-be predator of a Tomopterus worm, where that goo can get stuck to the face of the fish and potentially illuminate it to its predators there, thus leaving the predator potential prey there in the deep sea. I'd forgotten we had this video clip there of that bioluminescence there from the Tomopterus.
It's like the coolest thing ever, because it's just like a squid, the way squid ink, it's actually spewing out this yellow bioluminescent mucus and then taking off in the other direction. So it's sort of like, here, like take a look at this. And then, maybe it's also covering up the predator and making it even worse for that predator.
Yeah.
But then it's long gone and no longer vulnerable to predation.
You mentioned the
inking. Now we have an inking clip. So this is, again, Humboldt squid, and some squid ink and then take off. Some, like this clip, is showing that the squid is then sort of hiding in this big, huge cloud. It's almost like it's making itself look even bigger to a potential predator. And these Humboldt squid can be predators to each other. They are known to cannibalize each other.
Well, there you go. So thank you, Emily, for bearing with us. But it's such an interesting point here. I'm going to bring up a swordtail squid just because I have it here. But no, to your point, Emily and Susan, just these adaptations that we talk about, the red camouflage, the bioluminescence, all these different things, they're definitely not separate. Like, it's not a choose one. Many of these animals have overlap where they have many, many, many different adaptations, where so many different types of organisms have all converged on similar styles of staying safe in that deep sea environment. So what you see in a squid, a jelly might be doing something very similar. A worm might be doing that same thing. So many different adaptations there for life in the midwater. And if you're a big red jelly, if you're a deep red squid, it's a similar adaptation that all these animals have come around to. And you want to hide in that deep sea because even though there's a lot of open space out there, there's a good chance that if you get found, it's going to be a bad time. So trying to hide is really great. Emily,
Exactly. And
go for it.
no, Patrick, that brings up a great point to a question that I saw over on Twitch from Marbles, which is about how a lot of these animals evolved to have that coloration, especially when we were talking about that Tomoptera worm there. You can imagine that these animals, as they have evolved, having a red gut is just going to be better for them. So, a long time ago, maybe it was only a few of these worms that had that red gut, but those are the ones that are not going to get eaten by something else. And so then they go on to reproduce. And then their offspring then have that red gut, which then means that they aren't going to get eaten. So having those mutations in the genes of these animals is how a lot of these animals evolved to look and function the way that they function today that we see. These are animals that have been around for millions and millions of years. And so they've had millions and millions of years to evolve these adaptations that we see them using today. So those Tomoptera worms, 60 million years ago may not have had that red stomach. We don't know, but today when we see them, they do, because those are the ones that survived because they didn't get eaten because the predators couldn't see that bioluminescent glow inside of their guts.
Exactly right. And while you were talking there, Emily, I was playing Atola there. I think commonly known as the burglar alarm jelly, because it has this bioluminescent, these 8 bioluminescent organs that go in a circle to let other organisms know that they're in trouble. So the Tomopterid worm with the red gut, the Atola jelly, all those things happen over a long period of time and add up to amazing adaptations for all these different organisms. And back to that jelly there, the evolution of this particular jellyfish has led to our ability as researchers to study giant squid, because researchers using a similar type of burglar alarm that's based off of this jelly were able to attract a giant squid over, not because the giant squid was trying to eat this jelly, but because it figured, hey, something's bothering that, maybe it's a snack for me. So Susan, we've hit the half-hour mark, so just on a segue from there, all these animals, all the evolution that's gone on in the deep sea, that's a source of so much research for you and your team at MBARI and all around the world. All the deep sea researchers, going to pull up Deep Staria here. Susan, can you tell us what is it like to try to unravel these mysteries? You see something for the first time that's big and red, and what does this mean? What is it like trying to unravel those mysteries with your researchers when we're seeing things that we really don't have on land? What's that like?
Yeah, it's really fun to see new things. And one of the most common questions we get in the video lab is, how often do we see things that we've never seen before? And I would say on every single cruise, on every expedition, we see an animal that is not yet described by scientists. And it's because there's still so much that we're learning about animals in the deep sea. We may see animals that we know we can identify it over and over again, but we give it like a common name, a sort of a placeholder name that we use. And then once it is scientifically described, then we can change the name to that. And actually, here's an example, the mystery mollusk. We call it a mystery mollusk because it still hasn't been named, even though we've seen it many times, our researchers. It takes a very long time to go through the process of you have to describe the morphology, which is like the physical anatomy of an animal. And then now with all of the genetic techniques that we have, scientists are able to do a more thorough look at how the animals are really fitting into the tree of life. And they do this with obviously more than one animal if they can. And so it's quite a process to go through the process. I have lots of videos about that, all of the new things that we see on all of our research dives, our ROV dives.
That's amazing. Thank you so much, Susan. Well, with that, it's been about 34 minutes here that we've been live. Susan, how do you feel about a few minutes here of some rapid fire Q&A here with the audience that's tuning in? How do you feel about that?
Sure, that sounds great.
All right, Emily, rapid fire. Let's go through. What are you seeing out there?
Two rapid fire questions here for you, Susan. How far down is considered the deep sea, and what is the pressure like in the deep sea?
Yeah, that's a great question. We kind of consider below 200 meters is the deep sea. So that's, say, a few, 600 feet deep. And that's essentially where we really start to lose most of the sunlight. And that is where the light, it basically is making the habitat a deep sea habitat because of this lack of light. There's no animals that are photosynthesizing. And so all of the animals have adapted in that way. And the pressure gets very, very, very high pressure as we go deeper and deeper. And you can see in this video, this is a styrofoam head, like mannequin head, that we've put on the ROV and shrunk over the course of a dive. So this is we're going from the surface all the way to a couple of 1,000 meters, which is thousands of feet deep. And it's shrinking by many, many times. And it's basically all of these animals. That's another very common question that we get is, how do we bring them up and study them and have them still be alive? And it's because these animals don't have any air in them. The reason why when we go scuba diving, or even if you just go in the swimming pool and dive down a few feet deep, you feel the pressure in your sinuses, and that's because you have air spaces in your head and you have to equalize that pressure. But these animals don't have any air in them, so they kind of just equilibrate as they come up in this sampler, which we're showing here. That is Stella Medusa, which is a jelly, Stella Medusa ventana, which was also named after our ROV Ventana. And it's being sampled with a detritus sampler. We call this, essentially, our ROV pilots are so talented. They basically just fly the ROV so that the animal goes into that canister, and then the canister gets closed on the top and bottom, and then we can bring it up to the surface so that we can study it more in depth. Awesome. You're seeing the ROV here. You can really see the samplers and the HD camera. So all of these videos that we're showing are shot with that with a high definition video camera on the ROV.
And Susan, another kind of quick rapid fire question for you here. A lot of folks commenting about how we humans must look so boring compared to a lot of these animals that we're looking at right now. Do you have any favorite deep sea animals or favorite deep sea animal adaptations that you wish humans could have?
Ooh, that's a great question.
Well, that is a great question. And I will say, I don't know if this is an adaptation that I would necessarily want for myself, but one of my favorite animals is the viper fish. And it has teeth that are so big that they can't fit in its mouth. And it basically has a lot of the fish in the deep sea have really large jaws and mouths that they can open super wide so that they can engulf their prey. And what the viper fish does is it uses those teeth not to impale prey, the way we, and they're not like munching down on animals with their teeth like we do, but what they do is they engulf their prey and then use the teeth as bars on like a jail cell to keep the prey from swimming back out of the mouth.
That's
it's
amazing.
like the coolest thing ever. I can't say that I wish my teeth looked like that, but I do think it's like one of my favorite adaptations.
I would consider my teeth to be a really good cage for French fries these days. So maybe not, not such a bad adaptation there from the viperfish. Awesome. Emily, what else do we got?
That's one of my favorites.
That's awesome. Amazing.
We had another question here about needing to create pressurized like exhibits, holding pools, things like that for these animals when we bring them up to the surface. Do we do anything like that?
Yeah, so I just kind of covered that a lot of these animals don't have any air spaces in their bodies, so the pressure isn't the big deal when we bring them up. What is a bigger deal for most of these animals, so this is fangtooth, by the way, so a Noplogaster. It is another one of these fish that have really huge mouth, huge jaw that can open up really big. And anyway, so when we collect these animals, we have to keep it dark because they are definitely sensitive to the light. We also have to keep it really cold. The deep sea is very cold, and so they're adapted to these very cold water temperatures. And the last one is that everyone thinks of is the pressure, but we allow them sort of as they come up, they just very easily adjust. So we also have to keep the oxygen and pH levels in the water very similar, and it's very challenging to keep animals alive from the deep sea in the lab. Absolutely. Here's the anglerfish.
Yeah, I just
wanted... So this is also another really common bioluminescent animal that most people know about thanks to Finding Nemo, I think. They have a lure, which is essentially a flashlight that's hanging off of their head. And it has bioluminescent bacteria on that lure. So the actual fish is not creating the light. It grows bacteria on the lure that is bioluminescing. It's so cool.
That answers actually the next question that I was going to ask, which was, do any of them are actually creating their own light, true bioluminescence there, right, Susan?
Yes, and we have a group at MBARI. Steve Haddock's group is studying bioluminescence, and he is really looking at the chemical reaction of how these animals are creating the light, and then with interesting ones like the Tomopterid worm that's creating yellow light that's really unique in the deep sea. So they're studying that more deeply. It's a really interesting field of research that our scientists are going very deep into, and we've also developed some new high-tech cameras that are allowing us to film some of these animals in the deep sea so that we can see the light from the bioluminescence. So that means it has to be a super low light, special low light camera that can record this kind of light that you're seeing here. So we're actually now, like, all of these clips were shot in the lab, and now we're able to do this with a special camera with on the ROV. It's really exciting. We're just getting started on that project.
That's amazing. And just one bioluminescent animal that I kind of forget is bioluminescent. A fan favorite, I have the vampire squid up, also has some bioluminescence on it.
And this is a great, I mean, the other thing when you talked about favorite animals in the deep sea, I mean, when people ask me about the quintessential deep sea animal, I always think of the vampire squid, Vampiroteuthis infernalis. I also like to point out these are not very big. It looks really big and scary, and it has a scary name, vampire squid, but they actually eat marine snow. So all that stuff that's floating around them, all that white stuff in the water column, it's basically snot and poop and dead stuff falling from the sea surface down into the deep sea. And the vampire squid, that is what they're eating. It's like the coolest adaptation ever in the deep sea. They also spew. It's kind of like the tomopterid worm, where they can spew adaptation that we're still learning more about, but our researchers at Mbari actually described and vampire squid eat. So be sure to check that out on our YouTube channel. And I also want to point out that next week we're going to have Chrissy Hufford, who is an expert in cephalopods, and she's going to talk to you guys about deep sea cephalopods. So we're really excited to make this sort of a regular thing. So next week on Thursday at 2, I think, again.
Yeah, well, that's a perfect conclusion there. I think at the 45, coming up on the 45-minute mark there, we'll just wrap it up here. But yeah, we are hopefully going to be able to do these every Thursday at 2 o'clock. If you happen to be around there, we'd love to see you on the social media feeds. We'll make sure to have some of those video links there in the description here on this particular video. But I did want to pull up one last thing here, Susan, only because I know that we have some friends that are watching over on Twitch right now, and maybe some folks have tuned in and have watched us play Animal Crossing. We might see about inviting the Mbari researchers, Susan. You can ask them what they think about this. But I just want to point out that Spookfish is another fish that we'll talk about at some point with you in great detail. That is a character that features in that popular video game there, Susan. So Spookfish made it to Animal Crossing. I just wanted to bring that up with you. I just discovered that the other day.
Patrick. So we had that comment come through earlier in our Twitch chat that a lot of folks were recognizing that anglerfish that we had up there. Of course, in the game they call it a football fish.
Oh, yes, and the spookfish are actually also known as barreleye. We call them barreleye, but they have, just to very briefly talk about it, the two blue green orbs that are looking up through that clear fluid-filled shield are the eyeballs, and they're tubular, and they can rotate in their head.
Oh my goodness. That is incredible.
It is definitely the weirdest adaptation that I've ever seen in the deep sea. The things in the front, just above the eyes, that may look like eyeballs are actually the nasal passages. So they're like the nose.
Wow.
Yeah.
Emily, I'm sorry for shooting.
Obsession with Animal Crossing New Horizons. I am here to support you on that journey.
Okay.
No, I have seen a lot of cephalopod questions coming in about that vampire squid, and I just wanted to reiterate and mention again that with Chrissy Hufford, and so we're definitely going to get to all those vampire squid questions that we didn't get a chance to answer right now. So
YouTube and Facebook and even Instagram pages, Twitter, we're also on Tumblr. So
all right.
Can you tell that I'm the social media manager?
Yeah, well, this has been actually a deep sea show brought to you by the social media teams here at Mbari and the Monterey Bay Aquarium. So this has been really exciting, Susan. So glad to see you over there. Emily, any parting words for us from the folks over there? Anything wrapping up?
Anything wrapping up? I think that we just have a lot of folks saying thank you to you, Susan, for being here with us today, to answering all of our questions. A huge thank you to some of your colleagues who have been in the chat helping us answer questions as well.
Yes, we have a whole team helping us today.
We have a whole team, a whole backup crew that's behind the scenes right now helping us answer as many questions as possible. So huge shout out to them, and just a quick shout out to Patrick for pulling up all those videos and showing us all the cool clips of the animals this afternoon.
Well, thank you, Emily, for fielding all of the audience response. It's been really awesome to hear that so many folks are tuning in and looking at all that. Thank you for teeing those up. Thank you, Susan, for the knowledge, and thank you, of course, to Mbari just for so many decades of amazing work and providing us with these great videos. I think with that, everyone, we're going to sign off right now. Again, next Thursday, 2 p.m., we will do another one of these Mysteries of the Deep. Thank you so much for tuning in all across the internet on the Monterey Bay Aquarium social media platforms and on Mbari's social media feeds as well. Thank you for being there, and we hope to deep see you all again soon. Thank you so much, everyone.
Thanks, everyone.
Bye, everyone.